Welcome to Understand the Math. This video is part of a series of videos on linear algebra and its applications and covers section 4.3 on finding a basis for the null space and column space of a matrix. I'll outline the steps for finding each basis and walk through an example problem. Be sure to check out the link below for free guided notes that you can highlight and fill in as you watch this video. We'll begin by learning what the basis for a null space is and walking through an example problem. The basis for the null space of a matrix A is the set of linearly independent vectors x that are solutions to A times x is equal to 0. The basis forms the minimal or smallest set of vectors that generate all the solutions x. To find the basis for the null space of a matrix A, we need to complete 3 steps. The first step is to find x by augmenting matrix A with 0 and putting it in reduced echelon form. The second step is to solve for x and put the solution in parametric vector form. The third step is to set the basis equal to the vectors in the solution x. Keep in mind that the number of vectors in the basis is going to be equal to the number of free variables in the solution for x. Let's now walk through an example where we're given a matrix A and asked to find a basis for the null space of A. We'll begin by augmenting A with 0 and putting this matrix in echelon form. Our matrix is 1, 3, 5, 0, 0, 1, 4, minus 2, and we have zeros on our right-hand side. You can see that this matrix is already in echelon form, so to put it in reduced echelon form, all we need to do is get a 0 above our pivot. This gives us the matrix 0, 1, 4, minus 2, 0 on the bottom row, and then the next row is 1, 0, minus 7, 6, and 0. We'll now circle our pivots and solve for x1 and x2. x1 is going to be equal to 7, x3, minus 6, x4. And then our x2 is going to be equal to minus 4, x3, plus 2, x4. Our second step is to solve for x and put our solution in parametric vector form. Because A has 4 columns, our x vector has variables x1, x2, x3, and x4. And we'll now plug in our solution that we got from step 1. x1 is 7x3 minus 6x4. x2 is minus 4x3 plus 2x4. And then we have x3. And I think it sometimes helps to write this as x3 plus 0x4. And then we have x4, which we can write as 0x3 plus x4. We can now pull out an x3 and write this as x3 times the vector 7 minus 4, 1, 0. And then we'll pull out an x4 and write down the vector for that. That vector is going to be a minus 6, a 2, a 0, and a 1. We can now complete step 3, which is to find the basis for the null space. That basis is going to contain these 2 vectors. We'll go to the next page and write down the basis. Our basis is equal to the set of the 2 vectors from our previous page. 7 minus 4, 1, 0. And then minus 6, 2, 0, 1. Let's now learn what the basis for a column space is and walk through an example problem. The basis for the column space of a matrix A is the set of linearly independent columns of A that span the column space. This basis forms the minimal or smallest set of columns that generate all the other columns of A through linear combinations. Just like we did for finding the basis for a null space, we need to complete 3 steps to find the basis for the column space of a matrix. The first step is to take our matrix and put it in echelon form. We'll then identify the pivot columns and then set the basis equal to the pivot columns of A. Let's now walk through an example where we're asked to find the basis for the column space of matrix A. We'll begin by putting our matrix A in echelon form. I'm not going to go through the reduction steps here, but when you do them, you end up with an echelon matrix that looks like this. The second step is to identify the pivot columns of matrix A. Our echelon matrix shows us that we have pivots in columns 1 and 2, and that tells us that the pivot columns of matrix A are columns 1 and 2. For step 2, I'm just going to draw an arrow to these two columns. Step 3 then is to create our basis, and our basis is going to contain these two pivot columns. We have the vector 4, 6, minus 8, and the vector 0, 4, minus 2. When you're finding the basis for a column space of a matrix, be sure to choose the vectors from the pivot columns of A and not from the pivot columns of our echelon matrix. Be sure to check out the next video in this series where I'll teach you all about the dimension of a vector space.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.